Today I want to introduce you to this weird little bacterium that I've been researching for a little bit over 4 years now, and it's pronounced Wolbachia, although some say Wolbachia, Jack and Steph, and they're wrong. I'm also going to be introducing you to my superior word art skills. You're welcome. So, what is a Wolbachia? It is a bacterium that is an endosymbiont, which comes from 3 Greek words put together: endon, syn, and biosis, which roughly translate to within, together, living. So Wolbachia is a bacterium that lives inside of something else in some kind of relationship. To fully understand how this really works, you need to know how tiny bacteria are. So this is a crappy diagram I made in PowerPoint. You're welcome. And this brown pill square on the right here is the diameter of a human hair. And this purple circle next to it is the size of a generic animal cell. So that could be a human cell, that could be a bird cell, that could be an insect cell. So one cell is about half the size of a diameter of one human hair, so pretty small. And then you might notice there's this tiny little green thing down here. And that tiny little green thing is a bacterial cell. So bacteria are like super duper tiny, even though they're really, really important in health, obviously. And so when I'm talking about bacterial endosymbiosis, I'm not talking about bacteria floating around in organs, I'm talking about them inside the very cells of what it's living in. Wolbachia are even tinier than most bacteria because they've evolved to live inside of cells of many different things. This is Wolbachia. Not really, but Wolbachia is so tiny we don't have any good photos of them. Warning, there's like spiders and bugs and stuff on the next slide for anyone who might be afraid. So, Wolbachia live in the cells of other things. What other things, you might ask? This is some of the other things that it lives in. So Wolbachia lives in the cells of arthropods, which are basically insects, spiders, these things called pseudoscorpions, all the way down here. I don't know why they're not real scorpions though, so don't ask me. They also live in parasitic worms, that's why there's some worms floating around. And they live in quite a few different species. So when scientists go out and they survey different bugs and stuff and they say, hello sir, do you have a Wolbachia? They found that about 70% of the species that they've looked at have been positive for Wolbachia being within them, which is really weird because usually endosymbionts kind of evolve to just live within one or a few closely related things. And so Wolbachia is kind of freaky like that. And if that positive rate of Wolbachia infection of up to 70% is applicable to all arthropod species, so all your bugs, Wolbachia could be present in more than 4 million different things, which is a lot of things to have this weird little dude in. So, how do they get in things and how do they stay in things? There are basically 2 modes of Wolbachia transmission or infection. We've got horizontal transmission and we've got vertical transmission. So horizontal is here on your left, my right, and I've got a mosquito here as an example. And so horizontal transmission is usually when a Wolbachia will move from one adult to another adult organism. It could be the same species, it could be a different species. So say a mosquito that has Wolbachia takes a blood meal, takes a big old sip out of me, and then one that doesn't have Wolbachia were to take a sip out of me, it could potentially pick up Wolbachia that this one left behind in me. So it can transmit between adults. Then you've got vertical transmission, and this works very similar to how mitochondria are passed through. So they're passed down the maternal line, and so a mother, whatever bug it might be, can pass down Wolbachia to its progeny. Okay, so we've got this bacterium. It's in all these things, and it's passed down through 2 different ways. But what does it actually do? And I've just handpicked a few of my favourite things that Wolbachia do, but there's tons of them. And because Wolbachia is present in so many different things, it does different things to its different hosts also. So not everything I talk about is present all at once. So my first little example of that, my text screwed up, is feminization. This occurs in moths, beetles, and these bad boys, these butchy boys, roly-polies, what have yous. And so usually what happens when a mummy roly-poly loves a daddy butchy boy is they reproduce, and they reproduce at, a close to 1-to-1 sex ratio. So 50% of their offspring will be male, and around 50% will be female. But some scientists realized that in some butchy boys, this wasn't happening for some reason. And their babies were like 80% female and 20% male. And they went and had a look even further at this, and they found that this was occurring in Wolbachia infected butchy boys. There he is again. And so upon further investigation, we found that Wolbachia were actually inside the cells of the embryos of butchy boys. And because Wolbachia live inside the cells, they live like all up in the DNA and all around kind of the control center. And they can release molecules that kind of affect really complex functions. And for some reason, Wolbachia in some things, like butchy boys, have evolved to be able to screw up sexual differentiation. And so what was happening in these Wolbachia-infected butchy boys is they were making genetic males develop as pseudo-females. And so you have genetic males, as you can see here, this little orange bit poking through, that will develop what looks like female reproductive organs but weren't actually functional. And that was just because the Wolbachia wanted a place to live, and that's a nice place for them to live. Essentially rendering this progeny sterile also. Off the back of that, my next favourite thing that Wolbachia can do is male killing. It seems kind of on theme following the penises and the feminism. So it's basically when feminization goes haywire. I was about to say feminism goes haywire. Sorry. And basically what happens here is the male progeny of, again, this happens in beetles and moths, the male progeny just aren't viable a lot of the time. They do, some of them get through, because if not, they wouldn't, like the species wouldn't be able to exist anymore. But yeah, when Wolbachia infection is present, male progeny most often die because the males are screwing with the embryogenesis and the sexual differentiation of the male progeny so much that they just kind of go, you know what, no, this is too much for us. Scientists also went and screwed with this even more though. They were like, what happens if we take away the Wolbachia that is doing this? So they treated the beetles and the moths that this was happening in with antibiotics, killing the Wolbachia. And they found that when they take the Wolbachia away, the male progeny are viable, but all the female progeny die. And so somehow Wolbachia has positioned itself as like this control center and almost integral to like the homeostasis of babies, of beetles and moths. And it kind of just controls what babies can and cannot be viable, which is kind of weird. And my third example is parthenogenesis induction. So parthenogenesis is a thing that happens independent of Wolbachia, and it is the spontaneous development of an embryo from an unfertilized egg cell. So this can happen in ants and stick insects. If anyone's ever had stick insects, they can do this too, where basically if there isn't a male around, they can just fertilize their own egg and create what is essentially a clone of themselves. Pop those out and, in the hopes of buffing up their population until there are males around to bring in some diversity. And so what happens in Wolbachia is they just increase the frequency of parthenogenesis, and they essentially make their hosts into these like egg factories, which is really detrimental to their host. And they just do this because that means the Wolbachia can then go and proliferate in all these clones, essentially. So that's all weird, right? But why do we care? Apart from being weird. There are some things that Wolbachia do that is really important to human health. So I'm going to step away from arthropods and insects, and we're going to go into Wormtown for a little bit. And so Wolbachia is present in really gnarly parasitic worms of people. Parasitic worms that make people go blind, parasitic worms that cause elephantiasis, really gnarly stuff. And in the worms, the Wolbachia are in what's called obligate endosymbiosis, which means both the worm and the bacterium need this relationship. The worm gives the bacterium some essential molecules, some nutrients, and sorry, I think I screwed that up. The Wolbachia gives the worm essential molecules and nutrients, and the worm gives the Wolbachia a place to live. And so obviously we can use this to our benefit. We can now use antibiotic therapy in addition to anti-helmintic therapy like ivermectin, which should be used for worm infections and not COVID, to treat these terrible parasitic diseases just because the Wolbachia have made the worms reliant on them, which is awesome because if there is ever a resistance problem, we want more things in our arsenal against these things. So that's cool. Thanks, Wolbachia. And leaving Wormtown now, Wolbachia is a bit of a diva. So when Wolbachia is infecting a cell, it wants to be the only thing infecting that cell. And so this is really important when we think about mosquitoes that transmit human infections, or things that infect humans, such as malaria, dengue virus, chikungunya virus. And so we can actually use Wolbachia to lower transmission of these diseases. And we're doing this. It's called the World Mosquito Program, and we are getting all these mosquitoes, usually Aedes anopheles species, and we are infecting them with Wolbachia in the lab. And, well, I'm not doing this, someone's doing this. And then we're releasing them. And we're seeing if transmission of these illnesses goes down in those areas. And this is their most recent data. So they infected a whole bunch of mosquitoes with Wolbachia and they released them in, they released them in Australia, Indonesia, Brazil, and Colombia. And they found that there was 98% less dengue transmission in cans when they did this, and still significant less dengue everywhere else. They've also found that there's significantly less chikungunya virus being transmitted when we've released our little Wolbachia minions. And so this can be used to control these illnesses, and this will become even more important when it comes to climate change and these vectors of human disease being able to spread further. So that's really awesome. So that's Wolbachia. I hope you enjoyed this little crash course in my PhD project, which I wish was this fun all the time. Thank you.
Well, I'm both intrigued and horrified now. Am I positive for Wolbachia?
Probably, because we eat plants a lot.
Okay. Is it good or bad?
Neither.
Should I take ivermectin just to cover all bases?
Probably not, unless you have worms also.
For the COVID, got it. Cool. All right, enough of my dumb questions. All right, can I get some house lights, please? Excellent. All right, we've got a question. Back booth, yes.
If we're going to infect mosquitoes and stuff with Wolbachia, is that a problem for us?
If we infect the things with the Wolbachia, are we going to be fucked?
Probably not. The thing is we don't really know how long the Wolbachia lasts when we artificially infect it. So does it continue down the maternal line forever, or does it kind of fizzle out? We don't know. But it probably won't have any ramifications for us other than like, oh, it stopped working after a few years.
For now. All right. Yes.
Is there a way that you can sort of neutralise the Wolbachia? Like if they're in the mosquito, maybe they get prevented disease transmission, but then they also don't get transmitted to us and do that?
Is there a great Wolbachia neutralizer?
Well, Wolbachia don't really want to enter our cells, and if they do, I don't think they really do anything to us, so I'm not sure it's really a priority for us.
It's a bit rude. I feel very neglected and rejected. Yeah. Add it to the list. All right. Yes, over here.
The male species, or the species in which Wolbachia eliminate the male.
Kill all men, yep.
Surely they're reducing their real estate. Like, what's the point of that?
Why do Wolbachia want to kill all men?
I think it's actually a misguided attempt, well, obviously not with Wolbachia, they're not that smart, but of evolution to try and increase their numbers because they can only really follow down the maternal line. And so when they see a male embryo, they're like, you're of no use to me, I can't follow you any further. And that's why they kind of want to buff up the female numbers.
Sensing a theme of rejection in Wolbachia, just leaving a trail of sad things behind. All right, more questions? Surely there's more. Come on, man. No more wacky Wolbachia. Yes, in the back.
How does it affect the transmission of dengue?
How does Wolbachia, I'm saying it as many times as I can to hopefully get it right, how does Wolbachia prevent dengue fever transmission?
So basically Wolbachia increases the innate immune responses happening in the mosquito. And so when we think about immune responses, they're usually at like a baseline. And so when there's Wolbachia infection, it increases it. And so the cells kind of just like kill all pathogens instead of kill all men. It's in this heightened state. Yeah.
That's the neutralizer.
Yeah.
Kill all pathogens. Okay, that's fair. All right, we've probably got a couple more questions. We have time, if anyone. Yes.
So we're releasing Wolbachia into the environment, potentially, getting inside the water and getting infected. Actually have a protective effect because it means that the tapeworms and stuff are more likely to be responsive and protective of some sort of resistance.
Could we beat Wolbachia at its own game by releasing it more, taking more of it in, and then being protected from things?
Well, we can in arthropods, but with parasitic worms, I think the aim of the game is to just kill all worms, and so I don't see us kind of screwing with them too much. Yeah.
Strong thing. I have a question. What was it that led you down the wacky Wolbachia path?
Well, it was actually an interest in parasitology. So my PhD is mainly in the worm side of things, and there's a lot of really bad parasitic worm illnesses that don't get enough research because they don't infect white people. And then I learned about Wolbachia and I was like, holy shit, that's weird, and I want to do that more.
Hashtag not all Wolbachia.
Yeah.
Very good. All right, well, if we have no other questions... Oh, no, hang on, we do have more. Yes?
What's your favourite, out of the ones you've shown us, or there's another one, Wolbachia? Yes, I don't know what it is.
Manipulation, maybe?
Favourite Wolbachia host body? Corpse? I don't know.
I don't know if anyone caught it, but the feminization is my favorite because I'm trans and I joke a lot that it's transing the women, witchy boys. I just find it really funny.
We're here for it. We like that. All right, I think there was one more question around here. Yes?
If you infect the mosquitoes with Wolbachia, is it like bringing foxes to kill the rabbits into Australia, for example? Would that backfire?
Oh, okay. Is giving Wolbachia or putting Wolbachia into mosquitoes actually going to end up biting us in the ass?
I think we won't know until it bites us into the ass. Potentially, yes. So that's why we're doing it in like little controlled zones until we know a bit more, I guess. But yeah, 100% could have some foreseen adverse effect.
I mean, I've watched 28 Days Later and Contagion, so I have some strong feelings about
Well,
it.
it was actually about Wolbachia.
Was it really?
No.